So today's session is about electricity. Okay. Under electricity, we are going to study. In today's part, the first part, we are going to study about current electricity. We are going to see the definition of electric current. Electric current क्या होता है? And then we are going to see electric potential difference. That means how the electric current is produced in the circuit. What is the how the current comes in the circuit, that we will see as part of electrical potential difference. We are going to see Ohm's law, then we're going to see resistance and resistivity. Keep your camera on most of the time, okay? And the second part we are going to cover resistance and resistivity problems. In the first part also we are going to see problems now. In the second part also we will cover resistance and resistivity ka problems, and then combination of resistors. Okay? In the third part, we are going to see heating effect of current and electric power, and then we'll take a sample bill. Maharashtra ka ek bill lete hain, and we will check how to calculate how much amount you need to pay. Okay, shall we proceed? So electric current क्या होता है? End time कभी किसी को झटका लगा क्या करंट का? And have you end time touched the pin of the at your home? Have you end time touched the live wire and got a shock? किसी को शॉक लगा कभी कभी जिंदगी में? करंट का शॉक लगा किसी को? चैट में दबाओ, चैट में. नो नो, डिडंट गेट अ शॉक. और किसी को भी शॉक नहीं लगा. मींस वेरी फुल सेफ्टी. I got shocked at least 3 times in my life while operating the electric motor. One day I was operating the electric motor, and for some reason I touched the live pin of the electric motor. I was trying to connect the electric motor. That time, while connecting the electric motor, I got a shock. When I got a shock, I started trembling. I started getting vibration, and उसी वक्त वो लाइव वायर छोड़ दिया मुझे. Suddenly the live wire left off me. Now current went past through me. That means I was the conductor for the current. If I didn't wear the rubber chappal, I would have been khalas. I would have been what? Khalas. I've not been taking this lecture today. Okay, so whenever electric current passes into a human, if a human comes in touch with the electric current, he starts trembling. Why? Because the current creates a pressure. All the charges within the body start vibrating inside his body. They try to collide each other, and because of the collision, the current will get a direction to flow. And after some time, if you didn't wear the rubber chappals, you would just be electrocuted there only. You just stand still. There'll be no further vibration in you. Slight vibration will be there, and you will be charred off. Okay. So in our syllabus, what we learned as current electricity is mentioned to be the charge, the flow of charge. It's the amount of charge flowing to a particular area. That means if I connected this conductor here, this is a conductor connected to a battery, right? And due to this, the charges will flow into the conductor. We'll see this going forward. So electric current is the amount of charge flowing in a particular area of a conductor in unit time. Other definition is the rate of flow of charge. Electric current is the rate of flow of charge. How much charges are flowing in that circuit, that defines electric current. And what is the direction of this current? Direction of this current is along the positive charge. It is along the positive charge, but opposite to the negative charge, which is the electrons. Okay. One electron is minus 1.6 into 10 raised to power of minus 19 coulomb. Electron is negatively charged, right? It's a negatively charged, and current is in the flow of the positive charge. Current flows in positive charge direction. That means electron flow ke ulta. Okay. Then few conversions you need to remember. Whenever you get a problem, you have to see carefully whether the current is mentioned in amperes or whether it is mentioned in milliamperes. If it is mentioned in milliamperes, then what you need to do? You need to convert. You need to convert that. The conversion is 1 milliamp is actually 10 raised to power of minus 3 amps. Right? How much is it for microamperes? Can you type in the chat? 1 microampere is how many amperes? Can you type in the chat? Still, one person is saying no. No for what? Silo is saying no for something. Okay, can you tell what is 1 microampere equivalent to? How much is 1 microampere equivalent to? Can you type? Anybody knows? No. Micro is how many zeros will be there in micro? Can you hear me? How many zeros will be there in micro? 1 microampere is 10 raised to power of minus 6 amperes. Okay, याद रहेगा. Milliampere is minus 3 amperes and microampere is minus 6 amperes. याद रहेगा ना ये? कैसे याद रहेगा? मिली मीन्स -3, माइक्रो मीन्स -6, उससे ज्यादा. एंड हाउ इज इट मेजर्ड? यूजिंग अ एमीटर. एमीटर ऐसा कुछ होता है, ये पुराना एमीटर होता है. दिस इज अ वेरी ओल्ड एमीटर. द न्यू एमीटर इज समथिंग लाइक दिस. यू कैन सी this is a multimeter. You can see this is a multimeter. Using this multimeter you can measure current, you can measure voltage, you can measure resistance also, and these are the pins. Using the pins you can check how much current is flowing, how much voltage is flowing at your home, okay, or in any electrical circuit. So now this is the flow of the electrons. We said the flow of electron is happening. We said the electrons are flowing. Electrons are flowing towards the positive terminal of the battery. That means positive charge is attracting the negative charge. Positive terminal of the battery is attracting the negative charge. And because of this, what happens? What happens? Current flows in the opposite direction, the flow of the positive charge. Okay. So then what can we define as current? Can we see the formula for current now? If whatever charge is flowing in the circuit, if the charge flowing in the circuit is given as, if the net charge is Q, if the net charge flowing in the conductor or in the circuit is Q, in a given time T, it will be in some unit, it will be in hours or seconds, whatever it might be, then the current is given as QT, Q by T. That means net charge by the total time, okay, for the charge to flow. How you'll remember this? QT, if you remember QT, cute baby, if you remember cute baby, QT, cute T. Q का मतलब cute और T, cute T, ठीक है? Cute baby, okay? याद रहेगा? Type the formula in the chat. Current का formula in terms of charge and time, can you type in the chat? Both of you. I'm waiting before we proceed to the next topic. इतना टाइम, इतना टाइम. What is current defined as? Have you already typed, or is it taking time to for the chat to appear for me? You already typed, is it? Chilo, you already typed. What is the formula? We just learned the formula, no? Can you type in the chat box? Q by, divide by, not QT. Q divide by T. Very good. Only one person is listening here. Other person is sleeping. Huh? You have to be Q by T, right? It is given here in the other. This is the other slide here. Charge by time. That means what is happening? The battery here is filled with charge. It is highly charged, no? This battery here is highly charged. This battery is filled with charge, high potential. And because of high potential, it has the power. It has the power to push. It has the power to push the charges through the wire. That means the battery has the power. Give me the power. Battery gives the power for the charges to move into the wire. And because of that movement, what will happen? The light will glow in the bulb. The light will glow in the bulb because the current flowing through that wire from the battery. And the total current is given by charge by time. Okay. Okay, we'll solve a problem. Okay, this is the problem given. Can you solve it in 5 seconds? I'll time it out in 5 seconds. Can you solve this immediately? You already know the formula. You have typed the formula. So solve it now. If you have seen, the session already before, you will able to solve this now. 1, 2, 3, 4, 5. Okay. Anybody got the answer? Any of you got the answer? I didn't see any response. So let me solve it now. It's a very simple problem. अगर ये भी नहीं कर पा रहे हैं तो क्या होगा? आपको झटका लगेगा बाद में. लगेगा बाद में. करंट लगेगा बिना करंट पास हुए. Okay. What is given here? Current of I is equal to 3 ampere. How much current is flowing? 3 ampere current is flowing. This is what is given. For how much time it is flowing? For 4 minutes. How much time it is flowing? Type in the chat how much time it is flowing. Type in the chat how much time is it flowing. Type in the chat how much time. What is the time given? 4 minutes. Can you convert this 4 minutes now to seconds? What is being asked? They are asking the total charge. How much charge passes through the wire? They're asking how much charge is flowing through the wire. Acha, already I got one response. 12 coulomb. Okay, let us solve it now. Okay, we are going to use the current formula. Current is equal to total net charge flowing per unit time, right? Total net charge flowing per unit time. The next step is we rearrange it. You get charge is current into time, right? This charge will become current into time. And then time of 4 minutes is converted into seconds. After this, you can multiply with the current. You get 720 coulombs. 720 coulombs, right? जो किसी ने आंसर डाला उसका आंसर गलत निकला. What you did? You multiplied directly 4 into 3. That is why you got 12 coulomb. Right? You have to convert it to SI units, which is in seconds. You have to convert it to seconds. Okay? And then only multiply. Fine? Okay, we'll go to the next one. Next problem. Sorry, it's the same problem. What is an electric circuit? Electric circuit is, what is the definition? It's a closed conducting path that allows current to flow. It's a closed path. That means nothing in the circuit is open. There are no open ends of the wire. When you see a circuit, there'll be a battery. The battery will be connected with a wire, and that wire will be connected to a bulb. And the bulb again, other end of the bulb will be connected back to the battery, right? So the full circuit is a closed path. What is it? It's a closed path. This is a very important term. It's a closed conducting part. Can you type in the chat? What is an electric circuit? It's a closed conducting path. Can you both type in the chat? क्या होता है? इलेक्ट्रिक सर्किट क्या होता है? बंद. मेरी हिंदी, मेरा हिंदी. Going for a toss. Okay, tell. Okay, I got one response. Closed conducting path. Very good. Very good. Very good. So you see that this is the electric circuit, right? You have a battery here. You have a battery here, and this battery is connected. The wire is there, no? There's a wire here. The battery is connected to a wire, and this entire thing is connected then to a resistor, right? Then taken from one end to the other end, and then connected back to the other terminal of the battery, which is the negative terminal. So there is open end in the circuit. There is no open end in the circuit. There is no path in the circuit which is broken. The entire circuit is closed, all connected. Okay, let's proceed to electrical potential difference. Electrical potential difference. Okay, let's try to understand electrical potential difference. Now, how does water flow from your tank to your home? घर से पानी कैसे आता है नल में? घर से जो पानी आता है नल में तो आता है, वो टैंकी से आता है ना, टैंक से आता है. वो टैंक ऊपर रखा हुआ होता है. It is kept on top of the building. If you are staying in a flat, then the tank will be on the top of the building. That means at high pressure. Because it's in high altitude, it will be at a high pressure. And the tap is at a low pressure. Right? Because of the pressure difference, the water will flow. Right? टैंक ऊपर का पानी नीचे आता है. From top, the water will flow down. From top, top is at a high potential. Top it has a high potential. Okay, that is why the water will flow. Now, if you take an electric circuit, or if you take a copper wire, or another example I'll take. Apart from this, there is a waterfall also. You have seen a waterfall, no? Waterfall. ऊपर से पानी नीचे आता है, नीचे से थोड़ी ऊपर जाता है. नीचे से पानी थोड़ी ऊपर जाता है, ऊपर से नीचे आता है. High pressure to low pressure. Now, if I take a copper wire, what will happen? If I hold a copper wire like this, if I hold this wire like this, will current start flowing? If I hold the wire like this, will the current start flowing? Will it start flowing like this, like this? No. Pressure difference will not make any significance for electric wire. What will make a difference? It has to be connected to another source. It has to be connected to another source, and that source will have to be a battery or any external power source. It has to be a battery or external power source, right? Only then current will start flowing. So how does charge flow in a copper wire? It will flow due to a copper wire flow due to electrical pressure. That is called as the potential difference. So one part of the battery, or one terminal of the battery, is at positive potential. Positive means high potential. Negative means low potential. Battery देखा ना? You have seen a battery, right? One side of the battery is positive. वो लिखा होता है positive बोल के, that is high potential, and negative is at low potential. Now, because of the difference, the battery has the potential difference across the terminals. That means it has the potential. It has ताकत, due to which it can set the charges in motion. It can set the charges in motion. Then flow will happen for the charges. Okay. So now here we have taken a battery. We have taken a battery. This is a charged battery, high potential battery. And this is a low potential battery. That means there is no charge in this battery. This battery is taken from your car. The car battery is drained out. So now when you connect the high charge battery to a low charge battery, what will happen? Current will start flowing. Current will start flowing from here to here. Okay, due to the potential difference in this battery. Okay, potential difference is hence defined as the difference between 2 points. Sorry, I took the wrong indicator. Eraser, where is the eraser? So potential difference between 2 points is the amount of work done to move a unit charge from one point to other. Okay, the cell has to expend its chemical energy to give current in the circuit. The cell has to give its energy. काम करना पड़ता है cell को. It has to give away its energy so that it can give its energy for the functioning of the device. Okay. How is it measured? It is measured using a voltmeter. It is measured voltage, pressure, electrical pressure or potential difference. Potential difference is measured using a voltmeter, and it is always measured by keeping the voltmeter in parallel. Okay. So what is the formula? Formula is work done to move the charge from one point to another. How you remember? वो क्यों? वो क्यों? How you remember? वो क्यों? Voltage is वो क्यों? Okay, W by Q, or you can identify your own way of remembering. Okay. Okay, let's proceed. These are the two ammeter and the voltmeter, which is shown in the diagram here as pictures. So here you can see the graphical representation. What happens here? Here what happens is, initially the battery was at a high potential. Here there was charge. Now it got discharged. Why it got discharged? Because it gave away all its energy to the bulb or some other battery. The other battery which was at low potential, this battery which was at low potential, this was at low potential first. Now it became at high potential. Why? Because it got all its energy from the battery which was giving away its energy. So work is done by the battery, which is given by work by the total charge given. Okay. Can you type the formula for potential difference? Can you type the formula in the chat? Before we see a problem, can you see? Can you type the formula? Type the formula for potential difference. Can you hear me? Before we see a problem, type the formula for potential difference. इतना टाइम क्यों लगता है टाइप करने के लिए? Hello, why are you taking so much time to type, or is it network is very slow? Very good. Only one person is doing. Okay. What is the here now? Solve this problem. Try to solve this problem and type the answer. What is given here? Charge is given. What is the charge? 2 coulomb. 2 coulomb is moving to a potential difference of 12 volts. Right? What is the work done? It is asking what is the work done. So how do you calculate? It is we calculate by using the formula. Somebody has already typed the answer. Very good. Let's see. We use this formula. We rearrange the formula. Right? Voltage is work done by the charge. So now we substitute the values. What we'll get? 24 joules. Okay. So this was a very simple answer, I guess. So let's move ahead. Circuit symbols. This is given in your NCERT book. You need to remember. So this is an electric cell representation. Bada danda positive, small danda negative. This is the combination of batteries. That means many batteries are there here, right? How many batteries are there here? One battery, two battery, three batteries. Okay, they connected in series. Now we have a plug. Plug is open. When it is open, the dot is missing. If it is closed, then the dot will be there at the center. The joint of the wire. This is a joint of the wire, and this is a loop. This is an electric bulb. This is a resistance. This is a variable resistance. This is the ammeter and then a voltmeter. Okay. Now, what is Ohm's law? Ohm's law is Ohm's law is defined as the potential difference across the metallic wire is directly proportional to the flow of the current. What is it? It says that potential difference is directly proportional to the current flowing through the wire provided temperature remains same. Okay, that means voltage is proportional to current. It is also written as voltage is equal to current into resistance, and V is voltage, current, resistance. Okay, this is how it looks. Electrical pressure is applied, the resistance is applied on the current. Why resistance is required? So that it will tell, Are Baba, battery, the bulb will blast. If you give too much current, the bulb will blast. So wait, it will oppose the current. The resistance will oppose the current. Okay, resistance will oppose the current, and hence only required current will go to the bulb and it will light up itself. So this is the other representation. I is inversely proportional to resistance. So what will happen if resistance doubles? If resistance doubles, the current has to decrease by half. Okay. Then there is something called as a variable resistance. Without changing the voltage, you can regulate the voltage by using a variable resistance. We use a variable resistance. Okay. So with this, and this is the graphical representation for Ohm's law. That means voltage is linearly proportional to current. Okay, and the slope R gives the slope. Resistance is the slope of this particular graph, which is given by voltage by current. Okay, so this will take up in the next session, next part, factors on which resistance depends on resistivity, and then we'll see problems of resistivity and resistance in part 2. Okay, we'll join shortly in the next session. We'll meet in 5 minutes. Okay, 5 minutes break.